we're going to talk about automated malware analysis. And I'll give a brief introduction on what that means. So we have some problems that we have to face when we do malware analysis. Well, in the world there are too many, so we can go after all of them manually. And doing manual analysis takes a lot of time generally, so you have to go deep into reverse engineering and stuff like that, and you can't probably always do that, depending on what type of research you do, what type of analysis you have to do. And well, static analysis requires strong skill sets, and you have to face different type of malwares, different type of situation. You can face back polymorphic, self-modifying code and stuff like that that can make things more difficult. And well, performing dynamic analysis manually, it's kind of tedious work. So we can automate it, and we see that the solution is a sandbox. So what are the pros of running a sandbox or automating malware analysis? Well, you can automate the whole process most of the times. You can process high volumes of malwares, and that help you out facing what's out there. It's usable virtually by anyone. So once you normalize the results, they're consumable to normal users which are not properly malware analysts necessarily. So that's very good. You get the actual executed code. So if you run a malware in an environment live, then you will see actually what's happened during the infection and what the malware does when it gets deployed. So commercial solutions are generally very expensive, which was one of the reasons why I started the project at first. I was just a student, I couldn't afford buying a sandbox myself, so I decided just to build one. And another problem is that some portions of the malware code could not be executed. So you probably won't see all the capabilities of the malware, but just what it does under a specific situation. The environment could be detected, of course, since generally you instrument the analysis environment, you will leave some traces, and the malware could probably find them and try to spot that is running on a not normal environment, and you could terminate or fool the analysis, bringing random results. And it's difficult to successfully automate exploit analysis, mainly because exploit target different type of applications, different versions of applications, and you can always recreate all the possible environments where the exploit could successfully run. And most importantly, I think that without proper consumption of the results, it gets useless. So you don't want to have a bunch of XML files stuck somewhere without having actually the possibility to query them or search upon them and actually do some proper consumption. So that's a very key point. So when we try to deploy a sandbox or an automated system, there are some things that we have to take care of. You need to define your requirements and your expectation in advance. So you need a proper planning on what you expect and what you want your sandbox to do, what type of information you want from your malware analysis. You need to design the environment carefully. So you have to prepare everything in advance so that you can cover as most scenarios as possible. So you will need to think about what to install, which version of software to install, and things like that. And of course, as I said, you need to design and implement a proper use of the data and the results that get generated, and eventually integrate them in some larger framework or some threat intelligence framework that you already have, so that you can actually get a proper use of the results that a sandbox generates. So you need to ask yourself some questions. First of all, why do I need a sandbox? Do you actually need it? For what reasons? Why your organization needs to analyze malwares? And that's very important to understand before actually starting designing and deploying one. And what do you expect to achieve? So what type of information you're looking for? Are you looking for, I don't know, spotting botnets? Or are you looking for, I don't know, find new exploits or whatever? You need to know it in advance so that you can prepare the whole environment in a proper way. And as I said, what information is most relevant to me or to my organization? And who's going to consume the results and what for? So is it going to be a malware analyst? Is it going to be an IT security guy? Is it going to be, I don't know, a random analyst that doesn't know anything about technical stuff? So we need to know who's going to use it in order to better prepare the results in a consumable way. And that's exactly the point. Other questions, of course, do I want to analyze PDF exploits? Do I want to analyze Office exploits? Do I want to analyze PHP or other type of scripts? Do I want to analyze browser exploits? What else do I want to analyze? So in order to, if you know in advance what you want to analyze, then you can prepare the environment properly. So you can choose okay, I want to run PDF exploits, so the most exploited version of AutoReader is this, so I'm going to install this on the guest environment, as well as for the other type of exploits and documents and stuff. Do I want it to communicate with the outside? Do I want it to isolate it? Do I want to emulate the network so that it doesn't go outside and do shit around the network, but still I can see the communication that it does? These are all things that you should consider before. So in specific, we're going to talk about Cuckoo Sandbox, which is basically an automated malware analysis system that I developed. It's open source. It mainly makes use of virtualization. It's fairly easy to use and extremely easy to customize. And yeah, every single piece of it is open source, so you can tweak it, modify it, and do whatever you want with it. A little bit of history. So it started as a Google Summer of Code 2010 project with the Oninet project. And I started it as a student. In that same year, we participated with the DRG Security Innovation Grant. We didn't win it, no script win it. But then we participated again in 2011 in Google Summer of Code. Then we opened malware.com, which is a website that acts like a front end to a Cuckoo Sandbox in the back that you can submit malware and get results back. Then we are participating again this year in Google Summer of Code, and we recently won the first round of the Rapid 7 Magnificent 7 program, which is still running, by the way. So if you have any project that you would like to see supported, you can go to that website and you'll find all the information. So what it can do, it can analyze Windows executable PDF documents, basically any kind of thing you could imagine if you can script it properly. It can be fully customized to do whatever you want. So we'll see later what type of modules and things we can write and run. And it can easily be integrated with larger frameworks or other type of environments of storages that you have that could be used. The type of information it generates. So it generates a trace of the API calls being invoked by the malware. The dropped file, so the files being created on the file system or deleted on the file system. Some screenshots of the desktop while the malware is running. The network traffic dump, and some report, some comprehensive report. It's still unstable, so what I'm going to show you today is a development release. It's not ready yet. Will be released probably soon after the conference. So you kind of could expect some errors during the demo. So I'm kind of putting hands in advance. It makes use of some components. So it has a scheduler and an analyzer and other components that are made of that makes the analyzer basically. The scheduler is the main component. It's what basically dispatch all the analysis tasks to the pool of machines available. And it runs all the modules that the sandbox is provided to. And it's 100% Python code. The analyzer is basically the component that is instrumented inside the guest. So it's installed inside the guest and run. And it's basically what manages the whole analysis process inside the analysis environment. It's chosen depending on the platform. We'll see later why. For now, it's only for Windows, but it potentially could support other platforms. It's still working on. And it runs malware and does stuff with it. And also, this is 100% Python. And there's the C monitor, which is basically just a DLL, which uses a custom hooking library and gets injected inside the malware process. And it's basically what does the tracing of the API calls of the malware processes. It gets injected with different methods depending on how the process was created and stuff like that. And it logs the function calls to files that are later then parsed and information gets extracted. And C-hook is, as I said, a custom hooking library. Allows the definition of multiple trampolines, and we used it to replace Microsoft Ethers for a couple of reasons. The first one being that it just used one trampoline, which is just a straight jump, and it's very easy to detect, so we didn't like it. And while on C-hook, as I said, you can specify different trampolines. So for example, on every API call that we hook, it randomizes a trampoline to be used. So for each one of those, there is a different trampoline, which makes it slightly more difficult to detect. And the second reason is that I don't know really why, but basically every time you hook something with Microsoft Ethers, it will also load a DLL inside the malware processes. which is called detour.dll, and this is the content of the DLL, which is basically empty, so it does nothing. And that's very easy to spot as well, so it wasn't good enough. So the general execution flow of the Sandbox, it fetches a task from a local database. It prepared the analysis, so you see if there's some specific configuration and stuff like that. It launches on the virtual machine and then the analyzer inside the virtual machine. Then the analyzer execute an analysis package. We'll see later what that is. And once analysis is completed, it gets the results. They are stored, and then they are processed to create some sort of reports. So this is what it looks like when you start it. And I am going to show you. Okay, it works. I'm going to show you quickly how it looks like. So for this example, I will use a very unique and stealthy piece of malware that was submitted to my website. So this is what the Cuckoo directory looks like when you open it. And there's some utilities that you can use to submit stuff. So I'm going to submit the malware with, I don't know, let's say 25 seconds of timeout. And the path to the malware. So the task is added. And then now we can start the actual Sandbox. Hope it runs. Okay. And the resolution is quite low. Let's see if I can fix it. So yeah, now the virtual machine is launched, and now it's installing some components, preparing the analysis environment and stuff like that. And now in some seconds, it should start the malware. Yeah, this is a simple example of stuff that I get on my website, for example. Huh? Yeah, all right. So yeah, so this will run as long as the process runs, or as long as the timeout is hit. So if I want to specify the time, well, maybe I turn it off a little bit. So if I want to specify the timeout, if the analysis goes longer than that, then the virtual machine gets shut down, as you see now. And then it's running some processing stuff. Oh, it's working. Okay. So yeah, as I said, I can submit malware in different ways. You can submit with the command line utility that I just showed you, or you can use a Python API, or directly write to the SQLite database. You can specify the file path, the analysis package, which I'll show you later, and eventual options to the execution. And you can specify the machine that you want to use. So if you have different type of machines with different operating systems, you can specify which one of those you want to run the malware on. Otherwise, you can specify which operating system to use. So if you're running different virtual machines with different operating systems, you can just specify which one of those you want to run the malware on. And then you can specify a timeout and a priority. So there are different modules that basically constitute the Sandbox and that you can customize. So there is analysis packages, there is machine managers, and there is some processing modules, some reporting modules, and some signatures. The analysis package is a core component of the Sandbox, are basically just Python classes that define how the analyzer should handle the malware, how you should execute it, and how you should interact with it, and you can completely customize it. And yeah, you can create as many as you want, or modify the one that exists, and then you can specify them easily when you submit the malware. So it gets executed on that specific task. An example is the basic one for executables. As you see, there are three functions. There is a run function, which is the first one being executed, and there is a check function and a finish function. The first one you see just get the path of the malware, checks if there is some arguments to pass to the malware, so you can specify, I don't know, if the malware wants some argument to be passed from the command line, you can specify them. Then it gets executed, it gets injected, and it gets resumed if the process was previously suspended. And yeah, then it returns the process ID. The check function is used, it's basically executed every second during the analysis. and you can use it to specify some conditions. So for example, if you want to terminate analysis when a file is created, you can just place or check your condition inside that function, and then when it gets triggered, the analysis will terminate. The finish function is just a function that gets executed before the virtual machine is shut off. So whatever type of operation you want to do before the environment gets restored, you can do it in that function. A slightly more complicated example is, for example, for Office documents. So it's basically just the same thing. Instead of using the path to execute, it just gets the path to the malware and pass it to Word, to Office Word, execute it, inject it, and resume it. So some demos again. Okay. If I can fix the resolution. Is it good? Okay. So for this example, I'm going to run a DDoS bot, basically. And since I don't want it to go outside and do crazy stuff from the network, I'm offline and I will run a couple of scripts. So this is a simple fake DNS server. Okay. And then I will run just a simple HTTP server. So they're running on the host, and they will be basically respond to the malware when it makes some HTTP request. So now I can get the sample, which is this one. I'll show you how to use the a little bit. How to use the Python API, for example. So I specify the path. I can specify the timeout of, let's say, 50 seconds. Okay. Execute the sandbox. Virtual machine gets launched. So you can see this is the agent that is executed inside the VM, and it's exchanging stuff to run the malware. And now we should see, yeah. You can see that it made some DNS requests to these domains, and it should be redirected to our local HTTP server. So now it's running in the background, should run for about 60 seconds. In the meantime, the host checks every second what's the status of the analysis. So these requests are basically those. And it will shut down when the agent responds that the analysis is completed. Okay. So yeah, the analysis is finished. So now it's processing the results, and it should have created some stuff. So if we go to the analysis path, there is some files. So there is an analysis configuration which is created by the analyzer, and it contains some information, some options of the analysis. Then there is a log file, which will basically contain some information on what the analyzer did, and if something went wrong, and stuff like that. There is a binary file, there is a pcap temp, and there's the log files, which are basically just CSV files that contain the API calls. Yeah, this was empty. Yeah. And yeah, there's screenshots and the reports that are generated. So we can go to see an example of a report. Yeah, so this is an example of a HTML report that it generates. Yeah, there is some basic information, and there is the log file, there's all the screenshots that has been taken, some very basic static analysis if it's P32, so usual stuff, version information, sections, imports, and things like that. And then there's network information, so the DNS request it did, and yeah, the HTTP request that it did. So in this case, it was basically checking in with a CNC, trying to retrieve some commands. Of course, since I was emulating the service, it didn't get any stuff back, so it didn't proceed into the infection. Then we have basically the behavioral results, which contains all the chronological history of the API calls that it made. So yeah, there's a timestamp, the function name, the arguments, if the function succeeded or not, if we return a value, and how many times it was repeated if it was sequential. And yeah, so it contained everything. Now we can see, for example, an example of an Office document. So I'm going to use an exploit, the 2012-0158. So I'm going to copy over. I'm going to modify also the analysis package, so you can see. So yeah, this is an analysis package. I modified very simply to just wait for 2 seconds and dump the memory. So there are different type of functions you can use inside the analysis package. There are some APIs that are provided by default. Of course, you can add some more or replace whatever type of operation and code you want to run inside the analysis. And yeah, in this case, I would just want to dump the memory of Word while executing the malware. So I'm gonna add the exploit to the queue. I'm gonna launch Sandbox again. Hope it works. Okay. Now Office should pop up. Okay. Okay. So basically the exploitation was successful and it just opened an empty document. Okay. It was terminated quickly. Now it's processing. If we go again to the storage path, there's the same things as before, just a couple of more directories. So in this case, it dropped some files, for example. So if we go to the file directory, you can see everything is being created. So winword.x, for example, it's a payload that it dropped, so the malware that got executed. And then probably the other ones are just random stuff used by Office. And then there's, yeah, the same stuff as before. So there's on the log files, there's the reports, there's the screenshots, and then the results of the dump memory command that I launched. So in the memory directory, there's the process ID, a directory with the process ID. And then there's a timestamp of when the dump were created, and basically all the memory dump sorted by region. So yeah, there's all the stuff there. Let's see, for example. Yeah, so we can see, for example, the command in use to launch the malware and things like that. So every time we take a different snapshot of the memory, it will create a different directory containing all these files. We can go to see the report in this case. Yeah, similar thing. The analysis log, the screenshots being created, and then the dropped files. So there's some basic hashing information on the files that are being dropped. And yeah, network, which was none, and behavior analysis again. So other examples of analysis packages that you could create is basically anything that you could script with Python. So some examples of people that have been using the Sandbox have created, for example, an ONI client. So they just created an analysis package that takes a list of URLs, spawns Internet Explorer, and passes the URL to open so that they can see if it was an exploit and stuff like that. I have another friend, for example, that used it specifically to dump configuration and web injects of banking Trojans, SPY ITUs, and things like that. So he created a dedicated analysis package that spawns the malware, dump the memory, find the offset, and dump the stuff that it needs. A USB honeypot, for example, that's something I was playing with. I installed a USB honeypot inside the analysis environment, and I was checking if it was creating stuff on a fake USB device, and I can recreate a dedicated package for that, for the specific types of analysis. But it's basically up to you. So whatever you can script with Python, you can basically do it inside there. There are other type of modules that you can create and use with Cuckoo that are basically four. So there are the machine managers, the processing, reporting, and signatures. The machine managers is simply Python classes that define interaction between the Sandbox and the virtualization software. By default, I use VirtualBox, and it's very easy. So you have a struct that you can use for the class. You can specify the command that you want to use, and you can do it with everything. So you also do it with VMware, with KVM, and stuff like that. Then there are some processing modules. Basically, these modules are used to process the results, the raw results, and to normalize them and to give some context of the information. And they create a whole container that contains all the normalized information on the analysis. And yeah, you can create as many as you want. An example is just a simple module that gets some information on the file being analyzed. Another example, if you want to include various total results, you can create a processing module. This should work, I think. You can just specify the API key, and then you will have inside your container the antivirus signatures of the malware. And you can do any kind of stuff like this. So you just have access to the raw results, and then you can play with it and normalize it or do some analysis upon it and script it. And then you have signatures. So basically, signatures are, again, Python classes, and are used for looking for specific events. So if I don't know, if you're running a lot of malware and you want to find just specific type of malware, so specific type of information, then you can create a signature that defines some condition that is executed on the results. And if this condition matches, that it means that it's something that you want to give a deeper look at. I think it's very useful. So of course, you can assign a description and a severity level and stuff like that. And it's very useful because it gives context to the reports. So for example, if your users are not properly technical, they maybe don't understand what this API call or that API call means from a malicious perspective, giving a signature that gives a brief description of what that is, most of the time it's very useful for them so they understand better what the level of maliciousness of the malware you run is. And yeah. I can be used also for get email alerts, for example. So I'm personally interested in banking Trojans and in exploits and stuff like that. I created some signatures, and whenever my Sandbox at home runs into one of those, I get an email saying, hey, this malware trick this specific signature, so I want to give a deeper look at this. An example of a signature, it's very basic. This is a default one. It is included as an example of why you can write some. Just checking if you created some executables on the file system. I'm running through all the files being created and see if the extension is .x. Then the signature gets triggered. I specified a severity level, which is 2, a description and a name. Something more specific. For example, I want to look for PDF documents that loads the embedded Flash player, but that would probably mean that it's running a Flash exploit. So yeah, I create a new signature, specify a name, a description, a severity level, which is 3, which is high, and yeah, I'm checking if basically the file being run is a PDF or not. I'm going through all the processes, check if the process name is actually Acrobat Reader, and I'm going through all the API calls, check if the API call is a load library, and yeah, then I'm going through all the arguments of these API calls and check if the library being loaded is offplay.dll, which means it's the Flash player, the embedded Flash player, it's loaded. So I'll give you a small example of that as well. Oh, again. So for this, I'm going to use, I think, an older 2011 exploit. Seconds. Okay, so that's what I did. Then we can see that I created a signature and it's loaded inside the system. So you just have to create it and place it in that specific directory, and then it gets automatically executed. So then I can run the Sandbox again. Takes a little bit of time. Okay, so the PDF is opened. It's doing some nasty stuff. So the exploit is being triggered. Yeah. And in the end, it opened just an empty document with wrong written inside it. So that means that the exploit run, it probably dropped some malware or something like that. And yeah, it created an empty document and opened it just to give some sense of legitimate execution. Okay. So the analysis is completed. So if we go again to the results, yeah, we have the same stuff as before. We created some files. Then we can go to the reports again. We can find the reports being created. So I want to go through a little bit the structure of the results, or the normalized results. So for example, we also create a JSON report by default. It contains basically everything that the processing modules generated. So we can see that the signature was triggered and it was added to the report. Then yeah, it contains the behavioral results, all the API calls and things like that. A lot of stuff. It's taking too long. Yeah. So yeah, well, all the API calls, there is a process tree, and then there is a summary. So basically, just very specific information you might want to look for. So there's files being opened and created. So you create some temporary files, random ID reader stuff. So there's, yeah, this probably is the malware that is being dropped in the temporary directory. And then there's register keys that is being opened. And yeah, the mutexes that have been opened as well. So this is very useful if you want to look for specific indicators. You have a very small and easy summary of the files and the registries and mutexes that the malware did and created. So you can check up upon that. You probably find some specific indicators that give you some context of the malware. And then, yeah, there is information on the dropped files. The static analysis is empty because it's a PDF. I don't have yet a static PDF analysis component. And yeah, basically, yeah, the files created, there is a debug log and the network activity. This is just UDP stuff. And that's it. So if we go again to the HTML report, we should see, yeah, so we see, for example, that the signature was triggered, so it's highlighted as a priority thing. There's again all the screenshots and files and stuff like that. So reporting. The reporting modules are, again, Python classes. They use the normalized results that are produced by the processing modules. It take that, for example, the JSON stuff that you saw inside that, and do something with it. The one that I just showed you just created a simple JSON file containing all the information, but you can do whatever you want with it. So for example, with my website, I created just a simple module that gets the stuff, send it over to an API that gets it and store it into a database. Or you can use, for example, Mongo, which is another module which is inside Cuckoo by default. So I had a MongoDB database running locally while I was doing the analysis. And this is very useful when you do malware intelligence, if you want to do searches across the analysis results that you perform. That is very helpful. So we can connect to the database. Okay, so yeah, we have 4 analyses of the ones that we run. And we can do some nice searches across that, so we can find, for example, I don't know, let's see if I want to find all the malware, for example, that use a specific API call. So I'm gonna do a query saying I want to see if it used a create remote thread giver processes API. And then I want to get, let's say, the MD5, all the malware that did it. They should be correct. So yeah, if I want to search for this specific type of things, I can search across all the analysis results, and that's very helpful. So instead, if I want to search, I don't know, which one of the malware analyzed triggered a specific signature, I can do the same thing. So I'm gonna search for signatures, .name, bang, let's say creates, I don't remember, exe, and I want to get the signator's name and the MD5. So yeah, you can do these kind of things. So these are the results, all the MD5 with the malwares that triggered that specific signature. So you can do these type of searches, and it's very helpful for finding specific indicators. If you're looking for a specific malware family, you want to look for, I don't know, a mutex that is being created. For example, SpyEye creates a specific pattern of mutex. You can do these searches and find all the SpyEye malwares that you analyzed. So if you have a big feed of malwares coming into your sandbox, you can spot things easily. So there's another thing I want to show you, which wasn't exactly in the program. But so as I told you, As I told you, you can, as I said, create different type of modules that handle different type of things. For the machine manager, for example, in this case, I wanted to run Mac OS X stuff. So I created a VMware, a simple, I'm getting highlighted. I created a simple package that runs on VMware Fusion so I can run Mac OS X stuff, because I think it's the only one that actually virtualizes Mac OS X operating systems. So that's very easy. I just created a VMware module. And then I specified in a configuration file that I want to use that module for the virtualization. And then I created a configuration file specifying which virtual machine I want to run. So this is the path of my Mac OS X virtual machine, the platform it uses, Darwin and stuff. And you can create different type of analyzer. So by default, there's just a Windows one, but you can create Darwin or a Linux analyzer. We are working on having Mac OS X supported, but it's nothing ready yet. So I'm going to show you. Let's see if it works. So I added, this is the SQLite database. I added a simple text specifying that I want to run on Darwin. So yeah, it takes the different machine manager module and acquire the VMware virtual machine and run it. VMware Fusion is very heavy, so it takes quite a lot of time to run it. And it also slows down the network communication for some reason. Should have started. Okay. So the agent that runs in the guest is platform independent, so you can run it on any operating system and it should run fine. And then you have to create a dedicated analyzer that instruments the guest and doing stuff specifically for that operating system. In the case of VMware, I just created a simple one that basically just launched the malware and doesn't do anything else. But it is just to show you that it actually could do it and could be instrumented to do that. So I think it actually failed for some reason. Yeah. Okay, well, it's running. So yeah, it copied the malware to the home directory, and then it executed. This malware was just simply a shell script that just created a file on the desktop, and that's it. Yeah, but this is just to show you that you could port it to different platforms and running on different type of operating systems. It still lacks the guest analyzer component, so yeah, this is failed because I launched it manually. So I don't get any analysis results for Mac OS X. So if there's someone here that is a Mac OS X guru and wants to work on it, that would be really great. So that's basically it. So out of this, we want to create basically a community effort. So the next thing we're probably going to do is create a community repository where people could submit their own modules and signatures and stuff and share them. That is very valuable. So if you create some signatures that you want to make available to everyone, we'll probably be able to upload it there. And you probably could see other signatures that I have created and modules and things like that. We're still looking to expanding our lineup of developers and contributors. There's so much stuff that we need to do. There's so much work that could be done, especially on the post-analysis side, so processing the results, doing data mining and things like that. And then we want to grow Malware.com bigger and try to make it a major community research for malware research, community resource for malware research. And there's still some work that we need to do. This is still basically a development release. It's not public yet. It still lacks a few components that will probably be ready in the next couple of weeks. But in the long run, there's a few things that we want to do. We're still already working on a web interface that will be built upon the MongoDB database. So it will allow you to browse the results in the same way as you did with the HTML reapers, but also run the searches on the web interface, do some visualization and things like that. We definitely need to improve the Windows analysis components. So sometimes it's unstable, especially when analyzing complex applications like Office documents or browsers, exploits, and things like that, where the application to be analyzed is very big, is very complex, there are a lot of components and things to run. Sometimes it's unstable, so we need to improve that. And yeah, we would like to support multiple operating systems, not just Windows. Mac OS X will probably be the next choice. Eventually Linux. We had a prototype for Linux, but we didn't publish it because it wasn't really complete yet, and we weren't really satisfied. And, but we could basically implement any kind of operating system. In theory, eventually Android. We could create an emulator, use an emulator and create a component inside the Android system and plug it in as a module. Should work potentially. And also support native machines. So as I said, sometimes the malware detects some traces inside the virtual machine. I don't know, VMware VirtualBox components are very easy to spot. So running stuff on native machines sometimes it's better. It should be very easy to implement as well. So that's something that we want to do in the long run as well. Yeah, you can find some more information at these addresses. So the first one is the main website. Then there is a GitHub repository where you can find all the source codes, both for the Sandbox itself and for the DLL. And you can also find a hooking library there. So if you want to use the same hooking library that we use, you can find it there as well. Then we have a small blog where we keep updates. Malware.com, as I said, is a public interface that you can try out. It's just a running setup of Cuckoo with a web interface on top. It's still running an old version, so we're going to upgrade it next time with this new one. But it's ready, it's working, so you can try it right now. And yeah, also on the OnNet website, you will find some more information, the Google Summer of Code. If you want to participate, contribute, and things like that, you will find all of that here. Well, if you have any questions.
Is there anyone that has a question? I think we have just under 10 minutes.
Thanks, Claudio, for the talk. Very interesting. I want to know if I want to contribute with a Cuckoo installation. Suppose I want to set up a Cuckoo server at home or my company, and I want to connect it to your malware.com site.
That is possible.
Do you have an API, or does it work?
Yeah, so actually the first idea was to make it a crowd kind of thing. So we have some APIs, some keys that we can give you, and you can plug in your setup, and then you can submit the analysis that we receive and you perform as well to the centralized system. So yeah, that is possible. It will most easily possible in the next version of malware.com, which will be more structured and stuff, but it's already possible and it will definitely be possible.
Yeah, I think many companies may be interested in contribute and having access at the same time at the data that are processed.
Yeah, so the plan is to make the normalized results available as a data set to download. So I don't know, probably some JSON repository or something, or I don't know, Mongo dump or something like that you can download every day with the latest analysis. And yeah, we're probably also thinking on sharing the binaries that are being submitted, depending if the user agrees with it or not. But yeah, we're still working on it, so I'm not sure. Okay.
Nice demos, thanks. Just wanted to ask if you could give few examples of better. What is the best threat analysis framework to integrate with? Because you've mentioned it can be integrated with larger threat analysis frameworks.
Yeah, so there's, well, from my experience, at least in my own day job and at home, I integrated with private stuff, so we have our own systems and things like that. But we are working right now to integrate with a tool, which is basically a generator for wiki pages out of the analysis results. The CIF, the Collective Intelligence Framework, I think is also going to add a module for supporting that, I think. That's what I've heard, I'm not sure. But it's very easy. I mean, it's any kind of infrastructure of framework that you might have in your company or in your organization, that's very easy to implement. You just need a module using your own API functions that submit the results, so do whatever you want with it. That's very easy. I can't really name you a real complete threat intelligence framework that you could use for this kind of stuff, because I've just seen customized things, so things that have been built in-house. I don't really know about really open source things that you can use. Any other question? No? Okay.
Oh, okay, so thank you very much, Claudio.
Yeah, let's go get some more.